Our topic is chi-squared goodness of fit test, which is chapter 11 in the AP Statistics textbook.
For the chi-square test for goodness of fit, we have the same four-step plan that we do for other significance tests. And we start off with state. What we want to do is we want to state a correct pair of hypotheses in context. So our null hypothesis would mean that our distribution of the categorical variable in the population of interest is correct. And our null would be that our stated distribution of the categorical variable in the population of interest is not correct. And what that would look like, if we have an example, would be like, our null hypothesis would be moose have no preference for habitat type. And our alternate hypothesis would be that moose do have a preference for habitat type.
In the plan step, we include the conditions for inference and check to ensure that they are met. We have three conditions for inference in a chi-squared goodness of fit test. The first is the random condition. In this condition, you just check to ensure that data came from a well-designed random sample or randomized experiment. Our second condition is the 10% condition, which checks for independence. If you are sampling without replacement, you need to check that population is at least 10 times as large as the sample. So n is greater than or equal to 1 over 10 times little n, which is the population of our sample. For the large counts condition, you need to check that all expected counts are at least 5. You can do this by looking at your expected counts list in your calculator or one that is given to you with data and ensure that each are at least 5.
So for the do portion of this test, you first want to find the expected counts of each category by multiplying the sample size by the proportion of each category, and then calculate the chi-squared statistic by using this formula. And that'll be just the sum of all your categories, and you're going to add them together. You first have to find your degrees of freedom, which is just n minus 1, and then you'll look on your table to find your corresponding p-values.
You can use your calculator for the do step in the significance test. The first thing you need to do is enter your observed and expected counts into two different lists. You can do this by hitting stat and then edit lists. Your second step is to perform the actual significance test. You do this by hitting stat, then go all the way to the right and hit tests. You're going to have to scroll down until you find the chi-square goodness of fit test. This is written as GOF, abbreviated. Once you open this, you're just going to enter your values as lists into observed and expected counts. You have two options here. You can either hit calculate, which will give you your relevant values, statistic, and p-value, or you can hit draw. This will show you your chi-square distribution and the shaded area, which is the p-value that you're looking for. When writing calculator information on the AP test, you need to be sure you include your degrees of freedom, your statistic, and your p-value.
So for the conclude portion of this test, we want to compare the p-value to your alpha value, and if the p-value is greater than the alpha, then you fail to reject null. And if your p-value is less than your alpha value, so then you can reject your null hypothesis. And And if the test finds a statistically significant result, you should consider doing a follow-up analysis that compares the observed and expected counts that looks for the largest components of the chi-square statistic.
Your chi-squared statistic has different components for each observed and expected counts that are compared together. These different components are all added up to create the summation that is observed minus expected squared over expected. Each component is just the observed minus the expected of that specific comparison, and then these are all added up to create your total statistic. In a follow-up analysis, you're looking to see which component is the largest, which is the component that contributes most to your chi-squared statistic. A practice problem you could do would be from the 2008 AP FRQ number 5. You can find these online by just searching AP Statistics FRQs and then the specified year.